Algebra 1 students, welcome to the second half of your 3.7 notes, absolute value equations and inequalities. Today we're going to focus on inequalities. You're going to see some things that look very similar to what you saw with equations, and there'll be a few new things as well. So let's take a look at it. First of all, the process for solving absolute value inequalities is that you would isolate the absolute value, separate into two equations, and then solve. That looks a whole lot like what we did with equations, but we have one new thing to consider, and I'm giving you two made-up words to help you remember these new things, the words greater and less than. Okay, the reason we learn the words greater and less than, you can see down below. Right here we have the absolute value of x is less than a. So that means x is less than a, and x is greater than negative a. So you split it into two. With equations, we just had to consider positive and negative, but with inequalities, we actually have to flip that sign as well. So x is greater than negative a, where x was started with less than a. All right. In this second example, it's the absolute value of x is greater than or equal to a, and emphasis on the word or and greater. So x is greater than or equal to a, or x is less than equal to negative a. All right, so the word and comes from less than, the word or from greater. We'll keep those two things in mind, even though they're obviously made up words. All right, let's solve and graph the inequality. So here we go. Absolute value of x is less than 3. I've been really nice to you on this first one. It's already isolated, but note the symbol right here, less than. So I know x is less than 3 and x is greater than, flips the inequality, and switch the sign. So 3 becomes negative 3. I'm going to mark the two key points on the graph. There's negative 3. There's positive 3. It's open circles, at both places, and we connect. By the way, you could have written this as a compound inequality without the word and. You could have just written it as negative 3 less than x less than 3. That would be a great way to write your answer. Okay, let's take a look at the second one. Absolute value of y minus 1 is less than or equal to 8. I cannot separate until I isolate, and that is what we will do first. So the absolute value of y is less than or equal to 9. Now we can start doing the work. Notice again that it's less than, so we know y is less than or equal to 9, and y is greater than or equal to negative 9. Again, I'm just going to mark the key points. I'm going to call that negative 9. I'm going to call that 9. This time we have closed circles, so we can fill in those dots and then connect, and this would be the case. Y is less than 9 and y is greater than or equal to negative 9, and it was less than equal to 9 obviously as well. Okay, let's look at the opposite direction situation. Here we have the absolute value of x is greater than or equal to 5. So I'm going to say x greater than or equal to 5 or x less than or equal to negative 5. Again, flip the inequality, switch the sign. If it was positive here, it's negative here. And the word or comes from greater. All right, this is ready to graph right here. X is less than or equal to 5 and greater than or equal to 5, or x is less than or equal to negative 5. Again, I'm going to mark the key points. Now here's what's interesting about this. It's or. Typically an or graph is going to look something like this, where our graph goes opposite directions. And that's what we have here. The first one says x is greater than or equal to 5. That's this part over here. X is less than or equal to negative 5. It's over here. So the answer is here or here. Only one of them has to be true. All right. On number 4, again, the absolute value is isolated already, so we can go ahead and separate. So y minus 3 greater than 7, or, and then y minus 3 stays the same, flip the inequality and change the sign. And again, remember that word or came from the word greater right up there. Now, let's go ahead and solve these individually. We're going to add 3 to each side here, so I'll have y is greater than 10. If I add 3 here and add 3 here, I'll have y is less than negative 4. And again, the word is or. So here we go. I'm going to call that negative 4. I'm going to call that mark right there 10. We have open circles. Y greater than 10 looks like this. Y less than negative 4 looks like that. Okay, as we move ahead here, it just came to my mind that I neglected something on the previous problem. So go back and look at number 2. It's not a huge deal. We got the right answer. We graphed it correctly. However, I didn't write it as the compound inequality like you see there. So I'm going to go ahead and rewrite this and do negative 9 less than equal to y. That's this written backwards. And y is less than equal to 9. So you can write your answer just like that. Okay, that's a great way to write the answer. It's more concise. It makes it, I think, a little bit simpler when you look at the graph. It makes sense. All right, pause the video. Do number 5 and number 6 on your own. Then come back and compare your answers to mine. All right, welcome back, folks. We got 2 of them here. You can compare your answers to mine. One thing I want to highlight here is on the first one, number 5, when we divide by negative 3, just like with any other inequality, you do have to flip that inequality when you divide or multiply by a negative. So it was q, absolute value of q is less than or equal to 6. And then we could set up the inequalities from there. You can see the graph. This one was a little more straightforward. Break it apart. It was an or statement since it was absolute value of x plus 3 is greater than 4. And then you can see the work. All right. Here is another one. Multiple steps. This is the first time we've actually seen too much of this. It shouldn't be too much more complex than any of the others, but let's go ahead and walk through this. 3z plus 4 greater than 11, or 3z plus 4, switch the inequality and change the sign. So we're going to have to walk through and do a couple of steps of work to get this z isolated. So z is greater, 3z I should say, is greater than 7, and then that would mean z is greater than 7/3. And then over here, we'd actually have the same 2 steps. Subtract 4. So 3z is less than negative 15. Then divide by 3, and z is less than negative 5. And again, remember, this is greater, so the word is or. Okay, now, again, graph it. There's negative 5. These are both going to be open circles in this case. And then 7/3, I'm just going to decide that that right there is 7/3. The key is it's more than 5, so it needs to be over there to the right, of course. And that's what it would look like. All right, number 8's a little complex. Go ahead and pause the video, work through it, and see if you can get it figured out. All right, welcome back. You can see my work on number 8. And the only thing I didn't do here, looking at it again, is that I did not go ahead and combine the inequality into 1. I should probably do that. So it should be negative 4/3 less than equal to f less than equal to 4 would be the best way to write the solution. Although if you wrote it, f is less than equal to 4 and f is greater than equal to negative 4/3, that would be okay. All right, so take a look at the work. If you have any questions, bring those to me next class and we'll take a look at it. All right, one more topic for us to discuss, and it's what happens when you get a negative number over there, because absolute values, as we know, are always going to be positive. So we end up with some strange situations. Let's look at number 9. I'm going to subtract 8 from both sides. So the absolute value of y is greater than or equal to negative 3. When I have the absolute value isolated and I see a negative number over here, I can pause. There's only two possibilities here. One of them, it says right here, no solution, and the other one would be all reals. So in this case, what we're saying is, when is a positive number greater than or equal to a negative number? Well, that's always. So all we'd have to say here is all reals, and we'd be done with that problem. Let's take a look at the next one, though. We would subtract 5, and the absolute value of v minus 9 is less than negative 2. Again, we can pause right here as soon as I see an isolated absolute value and a negative number over here. We can stop. Again, it's one of two situations. And so what I have to ask myself is a positive number less than a negative number? Of course not. So we just simply write no solution. All right, I have one more. Has a couple extra steps, a little challenge here and there for you. But number 11, I want you to work that one on your own and then compare your answer to mine. All right, welcome back for the final time. You can see my work on number 11. This was a no solution problem. The key thing here, I think the easy mistake to make would be to forget when you divide by negative 1 to get rid of this negative, that you have to flip the inequality. So greater than becomes less than after that division by a negative, and an absolute value is never less than negative 1, so that's no solution. All right, folks, I hope this lesson works for you. I hope you've started to understand how these absolute value inequalities work, how we set them up, how we have to split into two inequalities. And remember, your new favorite words are fake words: less than or greater. I hope that this lesson's been great, and you guys have a greater day. See ya.